Carbohydrates are carbohydrates. Why? What makes them carbohydrates exactly?
The 1-to-1 ratio of carbon, hydrogen.
It's just the relationship of how much carbon, hydrogen, and oxygen there is in them. It's a 1 to 2 to 1 ratio. We went through monosaccharides, glucose, fructose, and galactose, all of which had the same formula, C6H12O6. That, by the way, is the molecular formula. To differentiate between molecular formula and structural formula, as you'll have to do on the worksheet today, just know that molecular formula means that, just the number and type of atoms, whereas structural formula is this. Right? That's the structural formula of glucose. It doesn't just tell you what kind of atoms and how many, it tells you how they're bonded together. Then we put disaccharides together. Glucose plus fructose makes table sugar. Glucose plus glucose makes malt sugar, and glucose and galactose makes milk sugar, which most of the world has a hard time digesting.
What is galactose?
That's an awesome question. I don't know. I think we should find out, though. My guess is we don't learn it because it's not common in nature. Like maybe that just doesn't happen very much, those two bond together, but we should find out what it is. And then we mentioned that the formula for these disaccharides isn't exactly what you thought it was, right? It's not C12H24O12. And that's because in order to bond those together, you got to take 2 hydrogens and an oxygen away. And that takes the form of grabbing a hydroxyl, an OH from one of the sugars, and a hydrogen off the hydroxyl of the other one and making water. And that's why we call it dehydration synthesis. And that's the only way you're going to see molecules get bonded together in this chapter, so it's worth getting to know that term. Any questions before we move on? Ask them if you got them. You're not the only one. You're just the one who has the guts to ask it.
Are we having a supply check today?
Yes, good question. Okay. Moving on to polysaccharides, which I'm also not going to make you draw, but I will show you pictures of. Polysaccharides, as you can tell, are just groups of more than 2 monosaccharides. Functionally, they're usually repeating chains of many, many, many monosaccharides. Who knows where you keep extra glucose in your body? Do you know? Fat is a place to store extra energy, but glucose itself, you pack glucose into branching chains of glucose. And you kind of, when you have an excess of glucose short term, what you do is you shove branching chains of it into your liver, and it's called glycogen. You store in your liver. And then when you're low, you send out a hormone called glucagon that causes that glycogen to be broken back down into glucose and sends it into your bloodstream. So that's your response to your blood sugar being low. Glucagon. I bet you know the name of the hormone that is your response to your blood sugar being high. The one that lowers your blood sugar? No? I'll give you a hint, it comes from your pancreas. I'll give you another hint, some people are unable to make it. Insulin. Yes, type 1 diabetics are unable to make at least enough insulin because they're missing the cells in their pancreas to do that. So that's animal starch, branching chains of glucose. Plants have a version of that too. It's called amylose. And it's what makes potatoes delicious. And pasta. And bread. And rice. And all the starchy things that are so good. They're good because you're programmed to like them because they are easily digestible calories. And we evolved for anything that's high in calories like that and easily digestible, like sugar, starch, and fat, to taste good. fire off our pleasure centers so that we seek out more of them. It's a survival thing. So those are interesting, easy to break down into glucose. And then kind of the opposite for the other two, cellulose, which is what makes plant cell walls crunchy, which is why when you eat celery, you spend more calories than you get from it just by chewing it up and digesting it. Mammals are terrible at digesting cellulose. It's really hard to break down. We're probably also terrible at digesting chitin, although I don't know. Mushrooms are good, but bugs? I don't think we digest bugs very well. At least not the outer part, which is what is made of chitin. What makes bugs crunchy? So glycogen and amylose couldn't be more different from cellulose and chitin, and yet they're all made of the same stuff. They're all just made of glucose. The difference is in how those bonds are formed, between which atoms those bonds are formed. Obviously, cellulose and chitin bonded together much more tightly, much harder to break down than the easily broken down glycogen and amylose. To give you an example of what those bonds look like, I'm going to have to introduce you to another version of lazy organic chemists drawing things weird. Although this one's kind of, it'll make sense. It'll make more sense when you get your hands in the models, okay? And remote learners, it'll make more sense when you get into the computer simulation, the virtual modeling. That what you see when you start to try to build glucose is it doesn't want to, that ring doesn't want to stay flat. It's like the two ends of the ring bend down and up. It's like you got a folding table and it keeps wanting to fold up on you. And so this is that the lazy part is, you know, what's here, 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 and here? Carbons, right? Those are carbons. Okay? Carbons here, 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 and there because, oh, and there too. That's a carbon. That's a bend, right? And so then you can see they're bonded between oxygens. We left an oxygen in one of the hydroxyls when we bonded them. And again and again and again and again, they're bonded, right? That's cellulose. There's chitin, which seems to have a few extra parts to it, a couple functional groups. Amino joined with like a weirdo carboxyl kind of thing. I'm not sure what that does to its properties, but something, right? But same deal. You got the carbons. This one's a little simpler at the angles. And what you'll see as you try to build glucose, which you are about to do, is that you're going to have to kind of flatten the ring temporarily to see where the up and the down spots on the carbons are. Here's what I mean by that. In glucose, you're going to build this carbon ring with the oxygen in it first. You're going to build that, you're going to flatten it out, and you'll notice when you flatten it out, three-dimensionally, there's always going to be an up and down spot. There's always going to be that up spot hanging off the carbon and the down spot, and you got to make sure when you're building glucose that the OH groups, the hydroxyls, go down, up, down, down as you go around the thing. You're also going to have to put the oxygen in the right place to get your bearings, and then make sure the carbon is sticking in the up spot. So that's the job today, or at least it's the second job. I'm going to give you a model worksheet, and I'm going to have you build glucose when you get to what is technically number 10. Okay, remote people. Obviously, you don't have molecular modeling kits right now, and so you can't build me a glucose. Two things about that, though. One,
I think we might have enough of these pieces of these kits that I'm going to be able to drop a little baggie of them in the place where you are going to be getting supplies on Thursday. Thursday's supply pickup day. So, assuming I can get that figured out, there will be a little baggie of molecular modeling stuff tomorrow um, that you are able to pick up with whatever textbooks and whatever materials from other teachers you're getting. You're not getting a textbook from me, but a molecular modeling kit is, I think, in your future. Until then, so for today's assignment, what I would like you to do is go ahead and answer the questions on the worksheet that I'm going to post. It's a PDF, and people seem to hate using Cami, so I'm going to have you just answer the questions either in a doc or on a piece of paper that you take a picture of. But when it comes to building the glucose and proving that you've built that glucose, here's what I'd like you to do. I would like you to go to the chemagic.org website that I have posted a link to. Go to the app and build me a glucose. Same instructions as I would give in-person kids. Make sure you get, this isn't it, by the way, this is a weird molecule I built that I need to clear out. But when you do it, you're going to be, putting your, oh dear, I've messed mine up. Anyway, you're going to stick a carbon in, and then you'll start building. Get that ring of carbons built, and you'll twist it so that it's flattened, and you'll see where the up and the down spots are, and you will build me a glucose that is correct. And by correct, I mean, we look at this stuff, and everything's in the right spot. The carbon.
Students, you should be reporting to 6 lunch or period 6-7 at this time.
So you put the oxygen in the right spot, you go to the left of it, the carbon should be pointing up, the hydrogen down, and as you go around, it's down, up, down, down for the OHs. Get that built
Sorry, you should
properly.
be reporting to 7-8 at this time.
This is my life, people. Once you get that built and you think it's correct, orient it so that I can see all the groups on it, take a screenshot of it, and post that in the assignment that I'll have there for you. Okay, so I'll probably just put a doc there for everyone in the assignment, and then you can just type your answers to the worksheet. You only need to do the front side of the worksheet and then post in and just copy and paste your screenshot in there. I believe it's I'll if you got a Chromebook, I'll figure out how to do the screenshots on those. I forget. I had it last year. But anyway, that is your version of that assignment, and I hope it goes well. Let me know if you have questions. Thanks, guys.